Okay, so next let's solve this problem. A 440 volt shunt motor has armature resistance of 0.8 ohm and field resistance of 200 ohm. Determine the back EMF when giving an output of 7.46 kilowatt at 85% efficiency. Okay, so this 7.46 kilowatt is the mechanical output of the shaft of the motor. So therefore, if you would draw the power diagram, this is our P input, which is equal to V input multiplied by I input. Then of course you have our copper losses, and then this will be our power developed in the armature, which is your TA or PA, which is equal to AB multiplied by IA, and then there will be friction and windage losses, friction and iron losses, friction and iron, and then lastly we have our power output, and this is the mechanical output developed, which is equal to 7.46 kilowatt. Okay, so using this 85% efficiency, since there is no given as electrical and mechanical efficiency, so therefore this is understood that it is your overall efficiency. So using the formula of our N commercial or our overall efficiency, we have our PO over P in which this times 100. So since we have 85%, so 0.85 is equal to our PO over P in. So we have our power output, which is equal to 7.46 kilowatt all over P in. So therefore we'll have our P in, which is equal to 7.46 all over 0.85. So from here our power input will be equal to 7.46 all over 0.85, which is equal to 8.776 kilowatt. Okay, so shift store at A. Okay. Now from this, next thing to do is of course to determine the back EMF. So determining the back EMF, we would determining back EMF. Of course, you would draw the motor, right? So our motor is a shunt connected. So we have EB, positive, negative, and of course you have our RA, which is equal to 0.8 ohm, and then we have our RSH, right, which is equal to 200 ohm, and then we have our power input, which is equal to 8.776 kilowatt. From here we have our terminal voltage, which is equal to 440. So therefore we have positive, negative 440 volts. So it makes sense that since this is shunt connected, our positive, negative Vs is also equal to 440 volts. So from here, of course, we have our current direction Is, IA, and our IL. I in, I should say. Okay, because it is already the motor. Now from here, if we would solve for our I in, so we can solve for our I in, which is, of course, we have our P in all over our V in. Our P in is equal to 8.776 kilowatt all over our V in, which is equal to 440 volts. So therefore we'll have a value equal to alpha A divided by 440. So calc. Okay, so we have this is times 10 raised to 3, so times 10 raised to 3 because it is in kilowatt, right? So therefore we'll have value equal to 19.947 ampere. Okay, so from this we have our I in. Next is our ISH, in which our ISH is equal to 440 all over RSH, which is equal to 440 all over 200. So 440 divided by 200, this will be equal to 2.2 ampere. Okay, now the next thing to do is to get our IA. So solving for IA, of course you would take KCL at node A, solving at A, solving for IA. So we have KCL at node A, in which we have I in minus ISH minus IA is equal to 0. So therefore IA is equal to I in minus ISH, which is equal to 19.947 minus 2.2, which will yield to, so alpha A minus 2.2, this is equal to 17.746 ampere. So shift store at B. Okay, so from that we already have our IA. After considering our IA, of course we would solve for our EB, right? So how will we solve for our EB? Of course we would take our KVL, right? So by taking KVL at this mesh or at this mesh, we'll have KVL at mesh 1. We'll have negative 440 plus VA plus EB equals 0. So therefore our EMF or our back EMF is equal to 440 minus VA. But what is our VA? Of course our VA is equal to our IA multiplied by our RA. So we're in IA is equal to 17.746 multiplied by our RA, which is equal to 0.8 ohm. So we'll have, so alpha B multiplied by 0.8, we'll have an answer equal to, so alpha B multiplied by 0.8, we have 14.197 volts. 14.197 volts. So therefore by substituting it to our A here, our EB will be equal to 440 minus 14.197. So we'll have 440 minus alpha C. So therefore we'll have a value equal to 425.802 volts or 03, 425.80278 or 8.03 volts. That would be your EB. Okay.